Hello, Bio20, and welcome to Cardiac Output, Stroke Volume, and a review on the pathways of circulation. Today, we are going to be learning about what is stroke volume and how it affects the amount of blood being forced out of your heart. We are also going to be talking about what contributes to cardiac output. To understand what we are doing, I need you to look at your success criteria in your book. Essentially, by the end of this, you should be able to tell me how cardiac output is formulated. So there's a little formula. What is heart rate? What is stroke volume? As well as what does the average person have for stroke volume and heart rate? As well as how do we indicate if someone is cardiovascularly, if they're very fit? So we're going to start with cardiac output and stroke volume. Anything I have highlighted in bolded terms is the stuff that goes in your notes. Now, you may have already copied the teacher notes down, so you should have most of this in there. As you're following along, if you need to pause, like I said, it's just the bolded material. Cardiac output and stroke volume is referring to the amount of blood pumped by your heart, and we refer to this as cardiac output. So how much blood is actually pumped from your heart around your body. We measure this in milliliters per minute. So again, for every minute, how many milliliters are being pumped out of your heart? Now, we indicate this because we are looking for the amount of oxygen delivered to the body so that muscles can do their job and perform properly. So cardiac output is actually really important, and there's two factors that contribute to it. So the two factors that contribute are both heart rate and stroke volume. So heart rate is if you were to take your pulse and count the number of beats you have in like 30 seconds and multiply it by 2, or for 15 seconds and multiply it by 4. That's your heart rate, the beats per minute. Stroke volume is essentially how much blood can be forced out of your ventricles in one pump, all right? So it's the amount of blood that is pumped out with every heartbeat that you have. In your notes, you have a little graph that shows cardiac output and blood pressure and their relationship. We learned last week that blood pressure is referred to as systolic and diastolic, and the highest pressure is referred to systole or systolic. The diagram that you have shows that when cardiac output is at its highest, so when your heart pumps all the blood out, it's also showing your blood pressure to be at its highest because systole is the highest pressure in your blood vessels. Cardiac output is all the blood being pushed into those vessels. So there's kind of a little bit of a review and relationship between the two. We need to look at cardiac output by taking these two things, heart rate and stroke volume, and multiplying them together. So someone's heart rate times their stroke volume will give them their cardiac output. So please make sure you have this formula written in your notes. Let's talk about the average person. The average person has a stroke volume of approximately 70 milliliters. Their resting heart rate is somewhere around 70 beats per minute. Therefore, if I were to take 70 times 70, I get 4,900 milliliters per minute, or if I convert it down, 4.9 liters per minute. So the amount, that's their cardiac output because I put the two together in the formula. How much blood is about in your body? And it's about 5 liters. So what does this mean? It means that the total volume of your blood in your body is circulated every minute. So if you were to stop, put a clock timer on your phone and timed it for 1 minute and took your heart rate, you should be, if you're around 70 beats per minute, it should mean that you are pushing all your blood around your body every minute. There is a little chart that you should be filling in all the bolded terms with at this point. So let's look now at the chart provided of the relationships between stroke volume, heart rate, and cardiac output. So in this graph, individual A is your average individual, resting heart rate, stroke volume, cardiac output. You'll notice the cardiac output is the same for everyone. So everybody is approximately pushing all the blood around their body every minute. What changes, though, is how strong your heart is. If your heart has not been utilized properly as a muscle, you haven't been strengthening it, you're going to have a lower stroke volume because the elasticity in the walls of the ventricles are not as strong. So if you look here at person B, their stroke volume is lower than the average person. That means that their heart rate has to increase in order to ensure that they push all the blood around their body every minute. So if your resting heart rate is higher, it means your stroke volume isn't as strong. You're not pumping all the blood out of your body. Oh my gosh, I keep saying out of your body. You're not pumping all of the blood out of your heart as well as someone with a lower resting heart rate. Person C, you can see, has a very high stroke volume. And we know that because their heart rate is so low. They only have 35 beats per minute, meaning their heart only needs to beat 35 times in 1 minute to ensure all the blood in their body is circulated. And that's because their heart is extremely strong. They are able to load the ventricles and squeeze out all the blood very well. So who is the individual with the lowest resting heart rate? That would be individual C. Okay, the heart rate is at 35. Who has the strongest stroke volume? It's also person C. They have the highest stroke volume, most milliliters per beat. Which individual do you think has the best cardiovascular fitness? That's actually individual C. Again, their heart is strong. They are able to reduce the amount of beats they need because their heart can pump out a lot of blood in one stroke. Now, someone like Michael Phelps, like if you know who Michael Phelps is, Olympic swimmer, his resting heart rate is super low, something like 32 or something like that. So he has a very low resting heart rate. The lower the heart rate, the higher the stroke volume, okay, means your heart is more efficient. See, it doesn't have to beat as fast. That's essentially what that question is getting at. Let's talk about heart rate. So stroke volume is hard to measure because we can't just go in our heart and be like, okay, but heart, pump out all this blood. Let me measure it in a cup. That's not going to happen. So instead, what we can do is we know we're going to push all the blood around our body in 1 minute. We can figure out our resting heart rate, which ultimately can give us our stroke volume. So what is heart rate? Your heart rate is your maximum heart rate is the highest heart rate you have when you're giving all out physical effort. So maximum heart rate is equal to 220 minus your age. So that's how you're going to figure out your maximum heart rate. Now, what do we look for when we're trying to obtain our heart rate? Well, we're wanting to ensure that we are strengthening our heart to ensure that our heart rate can decrease, because the lower the heart rate, the better, the stronger the muscle. So the heart, what is the most important factor? When you are measuring your heart rate, you want to actually take the length of time that it causes you to recover. So if you go and give yourself all-out exertions, go for a sprint, you do some rowing class, and you do whatever, and you go running, and then you take your heart rate by taking your pulse. How long does it take for your heart to return back to your normal pulse is essentially the indicator of how fit your heart is. The longer it takes, okay, the more you need to work out and the more you need to strengthen your heart. As you become more fit, that recovery time from the time that you have your highest maximum heart rate to your regular beats per minute will actually decrease. So we're looking at what is the best type of exercise to improve your stroke volume and to improve your heart. The answer is that regular cardiovascular exercise is better than strength training. The more you lift just straight weights, your heart doesn't get stronger, it gets thicker. Okay, think of how when you lift weights and your muscles on your arms get bigger, or like if you're trying to get abs and you're just doing lots of crunches and you're trying to strengthen those muscles. When you use strength training, your heart does the same thing, except the walls of your heart get thicker, which makes them less efficient to pump blood. So this means that you want to actually use cardiovascular exercise, so running, sprinting, Tabatas, and things like that, to actually help your heart become more efficient. So this, ladies and gentlemen, is now just a quick review of stuff we've already covered. I just wanted to review them really quickly because I know that we went through stuff fast last week. So you already have these notes. I just wanted to remind you about the pathways of circulation. So we're talking about our heart pumping blood all over our body. I wanted to remind you that when we talk about blood being pushed into our body, we are talking about the systemic, okay, circulation. If we're talking about blood moving to our lungs, which it does when we pump all the blood out of our heart to our lungs, we call that the pulmonary circulatory system, okay? As you can see here, this is just another version of the diagram I posted last week. You have your right and atrium and right ventricle, atrium and left ventricle, bicuspid, tricuspid, so the squares here. And it's just showing the movement of blood around your body. Any arrows that are red are oxygenated, meaning they have oxygen in them, and any arrows that are blue, okay, are deoxygenated. So this side, when it's moving from the right side to your lungs, is called the pulmonary, and this side from the left side to your body is called the systemic. So again, just a really, really quick review about things we've already covered, just bringing back terminology you may have forgot. If you have any questions, please let me know.